The best way to follow along with this course is to install Dart on your local system. We won't actually be using Flutter in this course, but I'm assuming if you're learning Dart, it's because you want to learn Flutter. And when you install the Flutter SDK, it also automatically installs Dart on your system. If your goal is to learn Flutter, I'd recommend going to the Flutter install site and follow the install instructions for your system, whether it's macOS, Windows, or Linux. Now, if you're not interested in Flutter and just want to install Dart by itself, you can do that as well. It's available in package managers like Homebrew, so you can install it with the brew command, or Choco on Windows, or your favorite package manager on Linux. Once that's complete, you should have access to the Dart command from the command line. In this course, I'll be using version 2.14. You can check the version by running Dart flag version, and any version above 2 should be fine for this course. If you already have Dart installed from Flutter and want to upgrade to the latest version, you can run Flutter upgrade from the command line. Now that Dart's installed, go ahead and open up an editor like VS Code to an empty directory. If using VS Code, there is an extension for Dart language support, so you'll want to make sure to install that. As you go through this course, I'd recommend that you follow along in your own editor to get hands-on with the code. But you can also clone the full source code on GitHub, and you'll notice that every file in that repo corresponds to a video in this course, so I'll be referring to it frequently. And you can also find the code snippets below the video. The final thing I'll mention is that if you don't want to work through this course on your local system, there's a web-based tool called Dartpad, so feel free to code along in Dartpad if you prefer that approach. Now that we have Dart installed, let's use its command line interface to generate a new project. Whenever working with a new CLI, I like to first run the help command to see which commands are available to me. So if we run Dart flag help, you can see it lists out a variety of different commands like run, compile, analyze, and so on. The first command we'll want to focus on is create, because that will give us a context for a new Dart project. The create command comes with several templates built in. There's one for a server-side application, one for a command line tool, and a couple of others. Running Dart create flag help will give you more details about those templates. In this course, we'll be building a simple command line app, so to facilitate that, we'll use the console simple template. The command is Dart create flag T with console simple, followed by the name of your application. That creates a new app in a subdirectory, or if you want to add the app to your current working directory, you can use a period as the app name, and then use force to force it to create the files in the current working directory. Just be careful with that and make sure that you are in an empty directory. Once that's done, you'll have a starter application in the File Explorer in VS Code. There's a few files in here, but most of them you'll never really have to worry about. The pubspec YAML file is where we would add packages to this project, but the actual source code is here in the bin directory, which means binary. In that directory, we have a dart.dart file, inside of which you'll notice a main function. That main function is the entry point for any Dart application. Now to actually execute the code, we can open up the terminal again and enter Dart run. The Dart compiler will find the main function and execute the code inside of it, which should print hello world to the console. So that's how we run the application, and we'll be using that command in almost every video in this course. Now the other important thing the CLI can do is compile your code to different targets. In this example, since we're building a command line tool, we likely want to compile it at some point to a standalone executable, something you can just run on your computer without any external dependencies or runtimes. To handle that, we can run Dart compile with the exe option and then point it to the file that we want to compile, which is the dart.dart file. After the command runs, it should create a Dart executable file in the bin directory. And now if you go ahead and type out the file path to that executable and hit enter, it should say hello world, just like it did when we ran Dart run earlier. That was quick and easy, but one of the real superpowers behind Dart is that it has the ability to compile to different targets. We can actually run that same compile command, this time with the JS option, and this time when it runs, it will create a file called out.js in the root of the project. And if we open that file up, you can see that it contains a bunch of JavaScript code. You can now take this code and run it in a JavaScript environment, like the browser or Node.js. As you can see here, I'm opening up the terminal, and because I have Node.js installed on my system, I can run node out.js, and it prints out hello world just like the other options. So now that you know how to run a Dart application from the command line, let's start taking a closer look at the Dart language itself. Now we're ready to write some actual Dart code. And to do that, I've created a variables.dart file here in the bin directory. go ahead and add a main function to it, and this is where we'll write all of our source code. A nice thing about Dart is that it has a very small set of built-in types, and many of these types we'll look at in other videos throughout the course. Now, if you come from a JavaScript background, you'll kind of want to just forget everything you know about keywords like var, let, and const, because they work a little bit different in Dart. To declare a variable in Dart, you typically start with its type. For example, to declare an integer variable, we would use the int type, followed by the variable name, then assign a value to it. Because we're using the integer type, its value needs to be a whole number. If we try to change it to a decimal or floating point number, you'll notice it gives us an error. That's because we're declaring the variable with the wrong data type. To use a floating point number, you'll want to use the double type. And as you can see, using the correct type removes the error from VS Code. Now there's also a bool type for booleans, which can take a value of either true or false. But now I have a challenge for you. What do you think happens if we try to add the integer number 1 to the double number 2? Is the result an integer or a double? One way to find out is to use the is operator, which will check the instance of the value to a known type. I'm going to go ahead and guess that the value is an integer. But there's actually another way we might check the runtime type. If you remember in the intro, I said that everything in Dart is an object, and that means we can take this number and check its runtime type, and that'll print out an actual string of its type. Let's go ahead and open up the console and run this code. To do that, I'll use the dart run command, but this time point it to this particular file, which is the variables.dart file. For the first line, it prints out false because the result is not an integer. It's actually a double, which we can verify by looking at the second line, which prints out double. So if you're ever not sure what the type of a variable is, you can use the is operator or runtime type to help you out there. Another common type that you'll use often is the string type. Notice how the string type is capitalized, unlike the number types we just looked at. A string value can be wrapped in single or double quotes, but you should generally prefer single quotes. When it comes to strings, there's one really important technique that you'll want to know called string interpolation, and basically it allows you to insert a variable or expression into the new string that's being created. If you want to insert a variable into a string, simply add a $sign followed by the variable name after it. Dart will automatically insert the value of that variable into the string. But in some cases, you may want to add a more complex expression into the string, in which case you can add braces after the $sign to create an expression that has spaces in between it to add additional logic and operators. Now at this point, we've been using explicit types for our variables, but it's important to point out that Dart also has a var keyword, which allows you to declare a variable and then have Dart automatically infer the type for you. Var is basically like saying, I don't care to annotate the type here. If we don't assign a value to it and then hover over the variable name, you'll notice that it has a dynamic type. That means Dart has no idea what the type is, which is usually not a good thing. You want to avoid dynamic types entirely if possible, but there are some use cases when it's unavoidable. Now, if we assign a value to it that's a string, and then hover over it again, you'll notice that it now has a string type. That's because Dart is automatically inferring the type based on what we assign to it, so that's perfectly fine. The other important thing to note here is that whenever you declare a variable, it's automatically reassignable by default. That means if we want to change the value of the variable later, we can do so by simply adding an equal sign with a new value. But what if you have a variable that shouldn't be reassigned after it's first initialized? Dart has a final keyword that you can put in front of your variable, and that tells the compiler that that variable should never be reassigned in the code. It's always a good idea to mark your variables as final if they're not supposed to be reassigned. It makes your code more explicit for other developers who might accidentally reassign a variable that they're not supposed to. Most variables are in fact final, so you'll see that keyword used very often in Dart codebases. But there is one potentially better alternative to final called const. At first glance, it appears to do the same thing, but it creates an immutable compile time constant. What that means is that the value must be known at compile time, and by marking it as a const, you can improve the performance of your code. If we have a variable that's just a static number, we can go ahead and define it as const. But if we have a number that's based on some other variable that is created at runtime, then we can't use const. It's generally a good idea to use const over final when possible, but it's not something you want to worry about too much when you're first learning Dart and Flutter. A much more important concept is null safety, which we'll look at in the next video. Null safety is a feature that was introduced in the version 2 release of Dart. The idea behind it is very simple. It just means that a variable cannot be assigned a null value by default. In our code here, if we declare a variable age and make it equal to null, you can see that Dart gives us an error. But in many cases, you may want to give a variable a null value. You might need to fetch some data asynchronously from an API, so naturally that value starts off as null. To make a value nullable, you simply add a question mark in front of the type. That tells the compiler that null values are okay here. That makes the error go away, but we actually don't need to explicitly assign null here, because when we add the question mark, it will automatically assign this variable to null for us. If we were to print out age equals null here, the result would be true. The reason null safety is useful is that it reduces runtime errors, and it can also simplify our code by reducing the need to perform null checking. If you ever worked with Flutter version 1, you likely have a lot of code that says if variable does not equal null, then do something. But in version 2, code like this is far less common. That's great and all, but it may cause some other caveats as you're writing your code. A common one is when you have a nullable variable, but then you want to assign that variable somewhere else to a non-nullable value. Even though both of our variables are strings here, one is nullable and one is not. So if we try to assign one to the other, it's going to create an error. Dart provides something called the assertion operator, which is just an exclamation point that you can attach to the end of a variable to make the compiler think that the value is non-null. You may need to do this to make the two types compatible, but it does increase the risk of runtime errors. You need to be absolutely positive that wherever you're using that variable is not going to have a null value, even though it may have a null value somewhere else in the code. Now, another situation that comes up often is when working with classes and properties. We'll look at classes in detail later in the course, but what happens is sometimes you have a property like size here that gets initialized, but you don't actually define it until somewhere later in the code, like in a method or the constructor. You could solve this problem by just making the property nullable by adding a question mark to the type, but that's kind of a hack because what if the value doesn't actually need a null value? It kind of sends a mixed signal in your code. To overcome this, Dart provides the late keyword, which allows you to keep the property as a non-nullable value, but initialize it later. Normally when we use the final keyword, we need to define the variable's value right away, but with late, we can do it later. In this case, we're not actually defining the value of the variable until this method gets called. So the bottom line is that late allows you to declare a non-nullable variable, but assign the actual value somewhere else in your code. Like the assertion operator, you generally only want to use this when it's absolutely necessary, because it's basically just a workaround that could result in additional runtime errors if not used carefully. In this video, we'll get a feel for the fundamental syntax in Dart by looking at control flow statements like loops and conditionals. The syntax is very similar to other curly brace languages and is almost identical to JavaScript in many ways. To create a conditional statement, we can say if, followed by parentheses and a condition inside of it, like color equals blue, then add parentheses to run some code inside of it. If we want to check another condition after that, we can say else if, followed by parentheses again and the next condition. And then finally, we can finish it off with else, which will be the default if none of the other conditions are true. It's also worth noting that for simple conditionals, you can omit the curly braces and put everything on a single line. Now, when it comes to conditionals in Dart, there's one thing I want to mention for any of the JavaScript developers out there. In JavaScript, you might check that a string is empty by simply passing in a string that is empty to the condition. That works fine in JavaScript, but in Dart, you'll need to actually check that it's empty by calling the toEmpty method, which will return a boolean of true or false. Another example in JavaScript is that when you pass null or undefined to a conditional, it defaults to falsy. If you need to check that a value is null, you'll need to explicitly check that the value does not equal null. So basically, when running conditions, you need to have an actual true or false value inside the parentheses, and Dart will always warn you when that's not the case. Now let's go ahead and switch gears over to loops. You can run a basic for loop like you would in any other programming language, and it also supports break, which would prematurely end the loop, or continue, which would skip this iteration of the loop and go to the next one. I'm not going to talk much more about a for loop because we're going to look more at that when we get to the list section. More often than not, you're working with a list when you're iterating over something, but I mostly just want to show you that for loops are possible. We also have while loops and do while loops, which will continue to loop while a certain condition is true. Then the final thing I want to show you with control flow is assert. Basically, it's a function that takes a condition as an argument, and if that condition is true, then nothing happens, but if it's false, it will raise an error. However, it only raises that error during debugging. In production mode, the error will be ignored. So basically, it's a way to validate the shape of your data before you start operating on it further in your code. In this video, we'll take a look at operators, and Dart has a few interesting operators that you may not be familiar with. It contains all the basic arithmetic operators you would expect, like add, subtract, multiply, and divide, and logical operators to compare two values, like equal to, less than, or greater than and equal to, and so on. If you want to combine multiple conditions together, you can use a double ampersand, which will require both of the values to be true, or you can use double bars for logical OR, which will require one or the other to be true. You can also increment or decrement a value by 1 using plus plus or minus minus, and these operators are very similar to many other programming languages out there. One of the more interesting ones is this double question mark followed by an equal sign. This allows you to assign a value to a variable, but only if it's not already defined. In this example here, if the value for name is null, then it would be assigned the guessed value on the right side. However, if the name is already defined with something else, then it will just keep the value that has already been assigned to it. And if you're not directly assigning a variable, you can just use a double question mark on its own, which will do the same exact thing, but it's just an expression that doesn't assign the value to a variable. Now, another very useful operator is the conditional or ternary, which is used as a more concise way to write an if-else statement. It's called a ternary because it can be broken down into 3 parts. The first part is a condition, or something that will evaluate to true or false. It's followed by a question mark, and whatever comes after the question mark will be the value that's used if the condition is true. After that, we have a colon, and anything after the colon will be the value if the condition is false. This one is also really useful to know for Flutter because it comes into play a lot when building out the UI based on different state changes to your application data. The final operator that I want to look at is cascade, which has a syntax of 2 dots when calling a method or accessing a property on an object. For this to make sense, let's first look at an example that's not using the cascade operator. As you can see here, we're creating an object called paint, and then we're accessing and modifying multiple different properties on that object. When it comes to Flutter development, you may want to do something like this when you're working in the widget tree, which would require you to create your own custom method or maybe some temporary variables to get the job done. What Cascade does is allow you to call a method or access a property on an object, but it will discard the normal result and just return the original object. That seems kind of strange, but it's very useful because in many cases you may want to modify some properties on an object, but you still want to return that original object to a function or maybe a property on one of your widgets. Another way to think of it is it provides a way to take these 4 lines of code we have up here and combine them all into a single one-liner, while returning the original object we started with. Now, to finish things off, one other operator you might run into is the as operator, which allows you to take a type and cast it to a different type. As you can see in this example, we're setting the number to an integer value, but then saying as string after it. If we then hover over the variable itself, you can see that it tells us it's a string, even though it's obviously an integer. Dart knows how to automatically infer the type, but in rare cases you may want to override its default behavior. This is not something you'll need to do very often, but it is good to understand what the as keyword means if you ever encounter it in a Dart codebase. In this section, we'll take a look at functions, and the first thing I want to point out is that functions are first-class objects. That means they can be assigned to variables and passed as arguments or return values from other functions, which makes it possible to implement functional programming patterns. In Dart, we don't have a function keyword. To define a function, simply decide on a name and then add parentheses to the end of it, then add braces, and you've defined a function. A function definition by itself doesn't do anything, so to call the function and execute the code, you reference it by name along with parentheses. Currently, the function has no return value, so it infers a return type of null. We can strongly type it by adding the type in front of the function name. We can then add a return statement that returns the corresponding type, and that would give us a function that we could then use to set the value for a variable. And in this case, we can actually remove the string type from the function definition because it will automatically infer that type based on the return value. Now we can also pass arguments into the function by defining parameters. Each parameter has a type definition and a name. Then when we go to call the function, we can pass those arguments to it. In this case, we have a positional parameter, which will always be required. But it's very common in Dart, and especially Flutter, to use name parameters instead of positional parameters because they generally make your code more readable. You can define named parameters for your function by adding braces around them. This will make passing an argument to them optional, but Dart will complain about that because it doesn't want to allow a null value. You can get around that by adding a question mark to the type to make it nullable, or you can add the required keyword to make that argument required when it's called. Another option is to set a default value with the equal sign, which will use that value unless a different value is passed when it's called. Now, when we go to call the function, we reference the arguments by name. We say name, value for each argument that we want to pass in. A is required in this case, and then we can optionally pass in a value for B as well. And unlike positional parameters, it doesn't matter which order we pass these arguments to the function. And again, I'll just mention that named parameters are very common in Flutter, and in fact, they're required on all Flutter widgets. In the last example, we used braces to define the function body, but there's actually a more concise syntax called an arrow function. The function definition looks the same at first, but when you get to the braces, you instead use an arrow, which will implicitly tell the function to return the value on the right side. In this case, it would return a string, and the benefit to writing a function this way is that you can fit everything on one line. This comes in really handy when passing functions as arguments, which comes into play all the time when working with Flutter, like when a user clicks on a button, you might have a function to handle it. In situations like that, it often doesn't make sense to name your function and instead just use an anonymous function. Here's an example. We have a function that takes a function as an argument, but instead of naming it, we just do parentheses with an arrow function, which keeps our code nice and concise and doesn't require us to come up with a name every time we want to define a function somewhere. To wrap up this section, I'll give you a challenge. Define a function that takes another function as an argument and then calls that function inside of its own body. That's known as a callback function and a feature of many different Dart APIs that you'll come across. One of the most useful objects in Dart is the list, which is equivalent to an array in other languages. The first thing I want to point out, though, is that a list inherits its behavior from a more fundamental class called an iterable. An iterable is just a collection of objects. The three most common iterables that you'll find in Dart are the list, the map, and the set. A list is like an array where each item in the list has an index. When you define a list, you can add a generic type using angle brackets. For example, if we want a list of integers, we add int as the generic type, then we define the actual list with brackets. This is known as the literal syntax for creating a list. Once created, you can then access individual items in the list using brackets followed by the index that you want to access. Or if you want to access multiple items at the same time, you can use sublist followed by the starting index and ending index. That will return a new list with only the items between those two indexes. It's also worth noting that there are other ways to create a list that don't use the literal syntax. A useful one is filled, which allows you to fill a new list with as many items as you'd like, and a static value at each index. This can be useful if you want to create a loop over X number of items. You can get the total size of a list by using the length property, and it also has first and last properties to get the first and last elements in the list. To push a new item to the end of the list, use the add method, or to pop an item off the end of the list, use the remove last method. Now, earlier in the course, we looked at how to set up a for loop, but you can also use a for loop on iterables themselves. We can say for n in list to loop over each item in the list. That's convenient, but we also have more functional options as well, like the for each method on the list itself. This will also loop over every item in the list and call a callback function for each iteration. And there's a variety of other functional looping methods as well, one of the most useful of which is map. It takes the original list and runs a callback on each item to transform the value into a new list. For example, if we want to double the integers in the list, we call map, then the callback function will multiply each one of those items by 2. Map is incredibly useful in Flutter as well, because you'll often have a list of data and need to map it to a list of UI widgets. And speaking of Flutter, another useful thing to know is how to combine multiple lists together. Dart supports the spread syntax, allowing you to compose a new list from one or more existing lists. Use brackets to create the new list, and then use a triple period to merge or concatenate the old list into a new one. Another cool feature of this literal syntax is that you can use conditional logic directly inside of it. For example, if you want to create a list of items, but one of those items should only be added based on a certain condition, you can just add an if statement directly inside of the brackets. And that's also a very useful one for Flutter when you only want to show a widget in a list based on a certain condition. Another type of iterable that you'll want to be aware of is the map, which is like a hash map or dictionary in other languages. It's a key value pair where every key on the left is unique, and points to some value on the right side. We can define a map with the map data type, and it also takes a generic, but with two different types in it. On the left side, we have the type for the key, and on the right side, we have the type for the value. Each entry in the map starts with a key, followed by a colon, then the value. Now, to access a value in the map, all you have to do is add brackets followed by the name of the key that you want to access. You can also use brackets followed by an equal sign to assign a value to a specific key. Now, in many cases, you may want to access all of the keys or all of the values as a list or iterable. You can do that with the keys or values property, which returns an iterable by default, or you can convert it to a list using the toList method. It's also possible to loop over a map directly if you want to access both the keys and the values. One option is to use a for loop and loop over the entries field on it. Each item in the loop will be a map entry object that contains the key and the value of that entry in the map. It's also possible to loop over the map with the for each method, in which case the callback function will have access to the key and the value. Maps are useful in Dart, but more often than not, when creating a new complex object, you'll create your own custom class, and that's what we'll look at in the next section. A class is like a blueprint for an object, and that means that every object in Dart is an instance of a class. In other words, a class provides a way for you to design more custom objects by combining different data types together. To create your own custom class, use the class keyword followed by its name, which should always be in upper camel case where the first letter is capitalized. Now, the code inside of a class doesn't actually get executed. In order to make use of the code, you need to instantiate or create a new object. We can do that by declaring a variable with the same type of the class that we just defined, then use the new keyword followed by the class name and parentheses. That creates a new object with a type of basic. But currently, since there's no code in our class, it doesn't really do anything useful. One nice thing about Dart is that we actually don't need to use this new keyword. We can just delete it altogether, and in fact, Dart will give us a warning with this blue underline that it's not required. That makes our code more concise, and it also makes classes feel a lot more like functions. Now, to make the class useful, we can add instance members to it. An instance member is data or functionality that is attached to each individual object. To create an instance variable, we can assign a variable inside of our class. Then we can reference that value with dot notation using whatever variable name we used when instantiating the class. But in many cases, you may want to pass data into the class like an argument to a function when instantiating it. For that, you'll need to define a constructor. A constructor is just a function that runs once when the object is first created. We're going to look at constructors more in the next video, but if you just want to pass some data into your class, you define a function with the same name as your class, then add this .variable name to reference a positional argument passed to the constructor. In this example, it will take the first argument passed to the class and assign that as its ID instance variable. So that's how instance variables work, but the other type of instance member that you'll want to define is a method, which is basically just a function that lives on each individual object. In the class definition, simply define a function like we've done in previous videos. The special thing to keep in mind here, though, is that your function will automatically have access to any instance variables on this class. When an object is created, it might have data or state that changes throughout its lifecycle, and your methods will always have access to the current state. That's how a basic class works, but one other thing I want to point out here is that you might also have static methods on a class, which are also just functions, but instead of operating on a class instance, they operate globally. Notice how I'm calling a method on a class, but I'm not using the new keyword or parentheses to actually instantiate an object. The reason this is possible is because I've defined a static method on the class using the static keyword. That can come in useful for more rare cases when you have a global helper method that doesn't rely on the internal state of an individual object. At this point, I'd recommend that you play around by building your own custom classes. Then in the next few videos, we'll look at more advanced concepts related to object-oriented programming in Dart. In this video, we'll take a look at class constructors, which tend to be fairly complicated because there are many different ways to do things in Dart. Remember, a constructor allows you to pass data into the class when an object is created, and can also allow you to run initialization logic that will only run once when the object is first created. In this first example, we're instantiating a rectangle object, and then trying to access a property called rectArea that gives us the area of the rectangle. To pass the arguments into the class, we'll go ahead and add a couple of final variables here, and then in the constructor say this.width and this.height to connect the inputs to the actual instance variables themselves. That's simple enough, but what if we also want to calculate the area when the object is first created? The constructor works just like a function, so we can add braces after it to run some code like the calculation of the area by multiplying the width by the height. The one caveat here is that we need to use the late keyword on the area instance variable because it's not actually assigned until after we have the width and the height values. Another thing to point out here is that in the constructor, you can use the this keyword to reference an instance variable, although it's optional and you only need to do that if it has a name collision with something else. And one other little thing I'll point out here is that if you want to add additional arguments to the constructor that are optional, you can do that by declaring a nullable value, then add brackets around it when referencing it in the constructor. The rectangle class we just created uses positional arguments, but the vast majority of classes that you'll find in Dart and especially Flutter use named arguments. They tend to make your code a little more readable because they define exactly what each argument is doing. In the circle constructor, we can add named parameters by adding braces inside of the parentheses. And notice how when we do that, they implicitly already have a name, so we don't need to declare the instance variables up here at the top. By default, a named parameter will be optional, but you can use the required keyword if it is actually required to construct the object. If it's a non-nullable value, it'll either need to be required or be set with a default value. But if it's optional and nullable, then you can just add a question mark in front of the type. Another little detail I want to point out here is that I'm using the const keyword in front of the constructor. When doing so, this allows you to instantiate objects with the const keyword. It's ideal to use the const keyword when you can, but it's not too critical of a concern when you're first learning Dart. Now, the final thing I want to show you is named constructors. In some cases, a class may want to have multiple ways to construct an object. Notice how we're creating two different point objects here. One is using the from_map constructor, and the other is using the from_list constructor. They're both creating the same object, but they're going about it with different inputs. In a class, you can define a named constructor by first referencing the class name, followed by a dot and the name of your constructor. The from_map constructor takes a map as its input, and the from_list constructor takes a list as its input. You'll often see classes in Flutter that use named constructors because widgets might have multiple different ways they can be created. Whenever you create a class in Dart, you are also implicitly creating an interface. An interface determines how the class will look to someone else using it in the codebase. Or in other words, it determines what the other developer will see in their IntelliSense when working with this code in a different file. By default, your instance variables and methods will be public, which means other developers will be able to see them. However, you may want to create a private member that's only available on the class implementation itself, like a method or variable that's needed to implement the class but shouldn't be used by the end user who's actually instantiating the object. We can easily create private members in Dart by simply naming methods or variables starting with an underscore. When implementing the class, you'll still have access to these values, but if the class is imported into a different file, then they won't be visible in the IntelliSense, and the compiler will throw an error if you try to access them. In the code snippet for this section, I've added a breakdown of what would be in the interface and what would not. Anything starting with an underscore would not, and it's also worth noting that the constructor would not because it's not a value that can be accessed by the end consumer of the object. One final thing worth noting is that if you just want to implement an interface and don't care about the implementation details, you can add the abstract keyword in front of a class. This creates a class that cannot be instantiated, so it's only there for the interface itself. The Dart language supports inheritance, which allows you to take one class and extend its functionality to a new class. You'll often use this feature in Flutter when creating a stateful or stateless widget, where you extend a base class provided by Flutter to create your own custom widgets. The base class provides the initial functionality, then you go off and extend and override it to do your own custom stuff. In the code here, we have an abstract class of dog, and that class has a single method called walk. That's the core functionality for a dog. Now we have a breed class of pug, and we want to give it this core functionality, so we say extends dog. This class will now automatically have access to that walk method. We can then add additional functionality on top of it, like an instance variable of breed that's its own unique value. But what if we want to change the way the walk method works? We can do that by simply overriding it in this class. Whenever you override a method or variable, it's a good practice to use the override decorator on top of it. Now, you could completely redefine the method and create something entirely new, but in many cases, you may want to use the initial functionality and just add something additional to it. The super keyword allows you to reference the base class, making it possible to call the original walk method, then implement your own code after it. This is a pattern that you'll also see often in Flutter when implementing a stateful widget that has a dispose method. The method provides a default way to dispose of data on the widget when it's destroyed, but you may want to do additional things here like turn off your own subscriptions when the widget is destroyed as well. So overriding the method is the way you achieve that. In some cases, extending a class is not enough, and you may want to add additional behaviors beyond the initial extension. One way to make your code more flexible is to create mixins instead of classes. Notice how we have some code here that looks almost identical to a class with instance variables and methods, but instead of using the class keyword, it uses mixin. Mixins are generally organized as behaviors. Like in this example here, we have strong and fast, which are behaviors that we can use to extend the human class with. So what we're doing is creating a new class called superhuman that extends all the behaviors of a human, but has additional behaviors beyond that class like strong and fast, and we can add as many of those behaviors as we need using the with keyword. And that gives us a superhuman that has all of the features of a human, along with the additional behaviors of strong and fast. Mixins are a more advanced feature that you generally won't need in Dart in the early stages, but it can be very powerful as you organize a more complex project. In Flutter, there are some libraries out there that use mixins, so it's good to understand what the with keyword is doing when you come across it. Earlier in the course, when working with lists and maps, you might remember how we define the type of the items inside the list using a generic type inside of the angle brackets. A generic is basically a way to pass a type as a parameter. A list is like a box or container that can hold many different types of things. A generic type provides a way to strongly type the things inside of that container. Let's go ahead and write our own implementation by creating a box class. When defining the class, notice how I'm using angle brackets with a capital T inside. In this case, T represents a variable type that can be anything passed in by the end user when instantiating the class. This allows me to then use T inside of the class definition. There might be a variable of value that has a type of T currently, but T will be replaced with the actual type like an int or string when the object is actually instantiated. And we could also use T in other places like the return value from a method. When it comes to Flutter, generics are not something that you're likely to implement on a regular basis. However, you will use them on a regular basis when creating objects, so it's a good idea to understand how they work. Like any project, one thing you'll often have to do is import code from one file to another. For example, in this file, we may want to import one of the shapes that we created in the constructors section of this course. We can use all of the public code in that file by simply importing the file name. And we now have access to the circle class that we defined inside that file. But there's a few issues that can come up here when it comes to name collisions. For example, we might decide to define another circle class inside of this file, in which case we have two different circle classes floating around in our code. By default, Dart will give preference to the one that we've defined in this file. However, if we want to use them both, it would be a good idea to namespace the library that we're importing. We can say import as, followed by a custom name like my shapes, and now we can access the circle class from that library from that namespace. In many cases though, you may just want to omit the one class causing the name collision. In a situation like that, you can use the hide keyword followed by the class name that you want to hide, and Dart just won't import it into the file. But in many cases, you may be importing a file just to use one single class inside of it. The inverse of hide is show, and show will only import that one class and omit everything else in the library. So that's how you import code from one file to another, but it's also worth mentioning that this same syntax works for packages that you download from pub.dev, because ultimately those packages are just Dart files as well. Dart provides excellent support for async programming out of the box. In order to use these features, we'll need to import the built-in library of Dart Async. It provides a variety of different functions and data structures to perform async programming, but the two most important to know are futures and streams. In this video, we'll look at futures, which are very similar to promises if you have a JavaScript background. A future allows you to perform some kind of operation in the background, like possibly a read to a cloud database, which would normally be a very time-consuming operation. Without something like futures, the rest of your code would have to wait for that operation to resolve before executing. Under the hood, Dart implements something called an event loop that is also very similar to JavaScript that allows certain things to be queued up in the background and then handled later with a callback function. You don't really need to understand how an event loop works to get started with Dart and Flutter, but it is good to know that that's the underlying architecture that makes asynchronous code like this possible. A future is a one-time event. Something asynchronous happens, then you either handle it successfully or you catch an error because something went wrong. In either case, the future becomes resolved and you'll never have to worry about it again. Let's take a look at an example in the code. It's created by using the static method delayed on the future class for a duration of 5 seconds. Now, there are two things that can happen here. It can resolve successfully, in which case we can pass a function to then that will be executed after the 5 seconds is up. But there's also a chance that the future will throw an error, in which case we can append the catchError method and pass a function there to handle an error case. So the bottom line here is that we have two mutually exclusive functions. The one inside of then will happen when it's a success. The one inside of catchError happens when it's an error. Only one of the functions will be called per future. Now, one cool thing about Dart is that it supports a syntax called async await. It replaces then and catch to write code in a more synchronous looking way. When you define a function, you can add the async keyword after it, in which case it will tell Dart to automatically return a future. The cool thing about it, though, is that you can use the await keyword inside the function body. Await will pause the execution of the function until the promise in front of it resolves, and that eliminates the need to use then along with a callback function, which can result in cleaner code. When it comes to Flutter, there are dedicated widgets that can resolve a future directly in your UI, and that can be really useful when you need to fetch data from a third-party API, among many other things. In the last video, we looked at futures, which handle one-off asynchronous events. But Dart provides another data structure called a stream that allows you to listen to multiple future events and handle them from the same place as they unfold over time. An example might be listening to a real-time data source, like the Firebase Firestore database, or maybe a WebSocket connection. It's not just a single event you want to handle, but multiple events in the future. We can create a stream using the stream class from Dart Async, then call its fromIterable constructor to create a stream of 3 events based on the numbers in this list. In this example, the 3 events will be triggered right away, but in the real world, they're often separated by long time intervals. Now that we've created a stream, we can listen to it using its listen method, which takes a callback function as an argument that will be executed for every event that's emitted by the stream. The result of this code is printing out the numbers of 1, 2, and 3. Another way to think of a stream is just a list that unfolds over the dimension of time. In fact, a stream has many of the same methods that you would find on a list. Like map will take the initial event and map it to a new value. But there is one really important caveat to understand when working with streams, and that's that they can only be listened to one time. At least that's the default behavior anyway. In this case, we have 2 listeners on the same stream, so if we attempt to run this code, it will actually throw an error saying that that stream has already been listened to. If that's not the behavior you're going for, you can turn the stream into what's known as a broadcast stream, which is one that can accept multiple listeners, kind of like how a radio station broadcasts its signal to multiple receivers at the same time. You just have to be there at the right time to listen to it. Now, the other cool thing about streams in Dart is that you can use the async await syntax on them as well. The difference, though, is that you're dealing with multiple values, so you'll treat it as a loop. Use the await keyword in front of a for loop for each value in the stream. The code inside of the braces will execute each time that stream emits a new event. What you've created is an asynchronous for loop, and this can make your code a little bit cleaner compared to setting up callback functions. When it comes to Flutter, you also have dedicated widgets for building the UI based on the value that's emitted from a stream. But the most important thing to understand is that a stream is just a way to handle multiple asynchronous events, which differs from a future, which can only handle one asynchronous event.